What's going on, chat? How's it hanging? Long time no see. How's everyone doing today? We zigging today? Of course we're zigging today. I have a little talk I'm giving next Tuesday that I need to prep for, so we need to get this on the road. Ocam will win. When you support Wasm, I'll do it. No, I'm just kidding. I do want to write some Ocam. I just have some other things I'm working on right now. Thanks for the sub. I appreciate it. There we go. Good stuff. All right, so let's hop right into it. Let's get right to the meat of it. All right, so what have we been building? I've been gone for a while. Where are we at? So I've been working on Zig Fermyon router, which for those of you who are unaware, the Fermyon, I will pull that up. Let's see, is a platform that basically allows you to run serverless WASM, or specifically WASI. There's someone in the closet behind you? No, why? Does it look like there's someone behind me? Oh, just saw it open. Oh yeah, I don't know what's going on. It's like kind of weird. Like I don't know what it is, but like if this part here just looks like a. I did just turn the AC on, so it might be that. My doors are weird. That would be kind of funny. I used to keep my testing hardware in the closet, but now I don't have testing hardware anymore, so I don't keep it in the closet anymore. And my energy bill thanks me for it. All right, so what are we talking about today? So Fermyon Spin is a platform to basically allow you to run WebAssembly apps, kind of like a serverless platform. I will be doing a little, classic haunted house. I'll be doing a bit of a talk with them on Tuesday of next week. So yeah, that's kind of the what I'm doing. So feel free to stop by. That's at, I want to say 1300 UTC. I'll have to double check on that, but you'll get a thing. I'm on it, guys. I'll get it. All right. So this is the TLDR here. I'm giving a talk about Zig, Wasm, and Wazi, and we need to kind of get some of this together so that this looks a little nicer. Basically, what this is it's a fully serverless Wasm router. So what does that mean? It basically allows you to do kind of a Go like if you've ever used Gorilla Mux. Let's look up Gorilla Mux. If you've ever used Gorilla Mux, it's kind of like that. Golem.cloud. Let's take a look at this. Invincible services. That's what does that even? Build your servers in any language. Interest peaked. Let's see. Get started. Just fill out this quick form. Where's the form? Where form? Sign up, blog, learn. It's currently in developer preview. Ooh, quick start. Eek. Oh, use the WebAssembly. Okay, so here's a quick thing. I did a little React recording, but didn't post it. Oh, cool. I would be interested. If you have the recording, I'd watch it. But basically it's something similar. Interestingly, so Fermyon also builds on the component model. Which is, you know, yeah, it's cool. Let's make sure. Oh man, am I muted there? Oh, thank goodness. Let's we'll switch this back to that one, so I don't accidentally deafen myself. Reminds me of lunatic.solutions. I'd not be surprised if there are many startups like me. Yeah. So here's one thing I do like about Fermyon. They just released Spin Cube, which is backed by it's a community project with Microsoft and SUSE, and basically allows you to run their Spin runtime on Kubernetes. So you can have a ton of WASM functions using Run WASM, which is really nice. Lunatic Solutions. Let's take a look. Interesting. So okay, so it is using WASI under the hood, so you could get technically like Zig with it, which is cool. Yeah, so I'm kind of digging this kind of Kubernetes operator, which is really cool. I think it's really great. It's got me excited enough that I want to spin up a cluster, which is never a good thing. Is there an actor model runtime for Zig? I'm not sure actually. Let's take a look. Actor model runtime Zig. Ooh. Let's see. It doesn't look like it, no. Should we build one? I mean, I don't see why not. We could. I'm intrigued by it. Yeah, you really are. You guys know where to find what really gets me going. And actor model. Very cool. So admittedly, there's a lot of things with Zig that are kind of, I feel like kind of blocking that right now. So the biggest one being that, hello. Do you think we can make a Zig backend for OCaml? Where's the code base for this? Someone have a link. Is OCaml's backend written in C, or is it mostly OCaml? Yeah, there's the one. All right. I'm guessing, yeah. So it's Lexer and stuff is all written in. What's this tiny slice of C code? There's a C runtime. Ooh. Let's see. Is this like what we're talking about here? Like kind of these standard library stubs? Or am I misinterpreting this? Yeah, wait, hold on. Well, Sarah, didn't you write the the bind gen kind of thing? Compile OCaml down to Zig. Now that's something I didn't think about. Now that's something kind of cool. You guys are killing me. No, you cannot get me to do this. But I am okay. I am kind of intrigued. I think we probably could. So Zig exposes its let's see, where's the GitHub? So Zig exposes its Zig docs. No, not this one. It's the other one. Nope. I think it exposes AST. Yep. So it exposes its own AST code. There's a even time, like the garbage collector is written in C, but I mean compile OCaml down to Zig. How do we deal with the garbage collector bits? Like, what's the memory story in Zig? I'm glad you asked. So let's talk about how memory works in Zig. So, Zig doesn't force you to use a specific allocator. So in like C, right, you get one malloc, you get one free. In Zig, you get to they have a unified allocator interface that you can use to kind of swap out what you want. So in this case, like I'm using a WASM allocator, but you have other things here too, like you have the standard heap. If we look at the allocators, you have a fixed buffer allocator, general purpose, which is kind of your allocator that you use for to catch memory leaks most of the time. You have a page allocator. You have a couple other ones. You can do arena allocation with it. Yeah. So you can basically write one. Yeah. So that's basically like what you do. So you can write like admittedly there's kind of this hard part where the Zig community isn't very fond of garbage collection. Why? Couldn't tell you. But you know, but yeah. So basically you could write like an arena like an allocator that functions kind of like a garbage collector, but they're kind of not about it. But I have been interested in like what that would look like. They want Zig to go over. Yes, correct. But like because you have that unified that interface, right? All of them are basically the same. So you just define like how pointers are and like where your v tables are, and it's really easy to implement. So you can really dial in your like what you need your memory to do in Zig. So yeah, I guess if we were gonna write OCaml that compiles down to Zig, we would need to write like some sort of runtime that handles the garbage collection. Yeah, arena allocation is great. I actually have an example of it. Hold on. In Meta, I will do my best to bring all my embedded stuff in, but I don't know if you want that. Also, I don't even have a Rust job. Why would you think that I could give you all of my knowledge and you would get a Rust job? Manually or so how do you do free dealloc? Right. All right, so here, so let me show you. So okay, I have a different project for this that's more representative. All right, so let me give you a good example. This is just kind of like the nice part. So when we talk about so this is a parser I wrote for protein databank files. It's kind of like what I've been spending my life doing for the last 6 months. Yeah, so you don't really have drop. You do have like a malloc and a free type thing. So in this case, right, we have like this is how we deinitialize the allocator when we're done, which this one, handles like checking for leaks. But if we actually want to use the allocator, because you get that unified interface, let's see the Atom record. What you do is you just pass the allocator in. So like in this case, we're calling like allocator.dupe, which under the hood is using, it allocates memory using this allocator interface. You do alloc, and then it does the memcopy it free. So then you do that, and then when you want to free it, you just do, if I can type on my split keyboard today, when you want to free it, you just call allocator.free on the element, and then it'll free it. Not exactly, because not all sys calls are. It's more accurate to call them like a built-in. So we can look at the... Yeah. So they aren't exactly syscalls. So yeah, so not all of them are syscalls. And that's something where it gets a little weird. So the OS abstractions are in Zig get kind of funky. But no, they're not exactly syscalls. But some of them are. But like so things like square root and some of your like standard options, also your vector operations, so anything with SIMD, those are also the same. But it also handles things like like some of the WASM primitives and stuff like that. But yeah, they're low level primitives, but they're not necessarily always used for that. But it does a lot of your like bit casting operations are here. I'm admittedly, the one thing I don't really like about Zig is this interface. I think that it just kind of adds syntax for the sake of adding syntax, I feel. It's fine, but I just wish it was, easier. Yeah, but you can do things like set the runtime safety for a given call. Okay. I see meta. You just want the embedded knowledge and professional experience. Got it. Understood. Yeah. For sure. Yeah. Good to see you. Thanks for hanging. Let's get into doing this. So there's a couple things that I want to do on this router, and we can kind of go through what we added and what we actually built out. You can actually go check it out right now if anyone's interested. It's very messy. Please don't judge me too hardly. I need to clean it up a little bit. But it works very well. So there's a couple cool things here about this. So you get a very Go-like interface where you can add a route. You say, this is my route. Currently doesn't do any regex. It only does raw queries. You pass it a handler. I'm still kind of working out some weirdness with Zig and doing like context so I can handle some other things. But that's what we get here. And that's kind of sweet. It's kind of awesome. But yeah. So we get this part built out, right? Where we can say, okay, cool, let's create a router. We're going to deinitialize it. What I want to do today is get this allocator, so you just pass it in once, and then it will reuse the allocator throughout this, which is kind of the goal. So what, rather than like having to pass it every time, so like a great example of this, so if we go to the root module and we do allocator, we're constantly doing this. There's no reason that this couldn't be embedded into the router itself and passed down to the request. And then you get that exposed as an interface. A couple other things this thing really can do. So you get this cool thing where you can use like multiple types for the methods. You can do like post in like this, or you can use the standard HTTP methods, which is kind of cool. You get a couple other things. And then the other thing that we get is we get a static routes handler. So you can actually provide it a file. It'll parse all of your files and create that. And the last cool thing that we built out is you get something called generate spin toml. So the spin.toml file is the file you need to actually deploy on Fermyon Spin. And this will generate that. So what it does is it takes these templates and will fill them out, given the information from the build step. So when you do a build, it'll regenerate a new build.toml file for you. So if you add modules or whatever, you get more, which is kind of cool. So you get an all-in-one solution. It builds the whole thing, and then you're done. And then one other thing. How would we go about tracking lifetimes of values? I don't know enough about how garbage collector, That's what I'm wondering too. I need to know more about garbage collectors. No, now I'm thinking about it. I will. Maybe we should do a stream on that, chat. Maybe we should do like a breaking down. Maybe we'll do the forbidden thing and write a garbage collector in Zig, and we'll see how it works. I think we could do it. Like, could we write a garbage collector allocator? Probably not, because you'd have to. But I think we should do a GC stream would be cool. I want to understand it better. So I'm interested. But yeah, so you get this cool generate spin toml file here, and then to kind of show a demonstration of this. So if we go to, this is another Zig project I have running. So if you go to the build.zig, it's pretty clean. There's part of this you can ignore, but basically you take the Fermyon router. We don't care about this part. This is some other fun things I'm doing. It's client side WASM, and this is the server side route WASM. And you just say, hey, I want to build this file. This is what the routes are going to be. It builds the whole thing. You link what you need to link, and then you say, cool, generate me the toml file, and there you go. You get a fully built thing, and it's great. So the cool part is you can build client side and server side WASM. So WASM and WASI in the same project, and they can play nicely with one another, and it figures it out. And the goal is eventually we'll integrate with Zin, which is Loris's static site generator built in Zig. So you can build that. It knows where to find everything there. It does the static site generation, and then it gets spit out, and then you can launch it serverlessly on Fermyon. All in one go. Yeah. I think there might actually be an update to the Fermyon build spin.toml, but I need to. That's going to break everything, probably. All right, so let's kind of walk through this. What do we want to do? We need to move the allocator inside. So let's do a little builder pattern here. So we'll say like allocator, standard mem allocator. Let's do a little copilot disable today. Okay, so we have an allocator. We'll give it a default, which is standard.http or standem keep wasm allocator. Yep. And then that means we can remove this. I guess we will need this then. Yeah. Okay, so then we'll say dot allocator. Nope, I wanted that there. Nope. All right, cool. All right, so we have the allocator moved in here. So now we should be able to do okay, add route. All right, so now we need to find where we use an allocator, which I don't think we do here. Okay. So in this case, we can just say, do we have a D in it? Yeah, so here we call, okay, cool. So we don't need it. Self.allocator. Okay. All right, so I guess instead what we're going to do is we're going to say here, and let's go. Oh, nope. Oh, interesting. Oh, yeah. Of course, Mitchell has some like garbage collector thing. That one's getting starred. So let's take a look at this. Hmm. That is fascinating. How is this being done? Source. Okay, what's being vendored? I'm curious. Oh, okay. Yeah. Yeah. Yeah, the garbage collector. Yeah, so this is linking against libc, or this garbage collector header, and then we're using that under the hood. Fascinating. So I guess here was my question. Do we pass it a base allocator? Probably not, because it's using C under the hood. Yeah. It would be cool though if I could have one where I could pass it a base allocator and then turn it into a garbage collected one. So I could pass it the WASM allocator and then say, hey, here you go. I need a new vibe on the music here. There we go. But yeah, that would be really cool. Like, I think it would be cool to do something where you can take like your base allocator, kind of like how the general purpose allocator works, and pass that in and use like build on top of it that way. Would be very interesting. Cool, cool. All right, cool. So let's see if this thing can build. No. I think there's actually a better way we can. Okay, so we have it here, and we just need to set the allocator. Okay, cool. Yep, so that works, and we can validate it by going to boom. Yep. So if we do there we go. We need to clean this up a lot, actually. Oh wait, I have debug enabled, so that's fine. All right, cool. And then route request is the next one we don't want to have to call an allocator with. All right, let's see. So we just did this here, which was, I guess, not really. It was kind of low-hanging fruit. So let's try this one here, just kind of a big one. So we're going to... All right, so let's just do... For now, we can do this. Wait, what did that say? Source route 228. Expected a pointer to an allocator. Can I just point or reference? Yeah, so I guess we'll do I don't know why I'm passing a reference of the allocator in. I guess so I don't copy it around, but there we go, baby. That's what I like to call an allocator. Interesting about the garbage collector there. Suboptimal compared to proper GC implementation in language runtime or a garbage collector written in application space. Yeah, that's what I was wondering. I don't know a ton about that specific garbage collector, but I'm curious. I'll have to dig into that a little bit more. I do really wanna build a little garbage collector. I think it'd be fun. I feel like it's gonna be crazy though. Now, every time someone says, you know what, let's sit here and work with memory, I get a little scared. But you know what? I think it'll be okay. I think we can do it. It would be very cool. We could allocate all the memory and just get rid of it. I think actually in this case that would work really well. Admittedly, in this example, I don't actually use a lot of my memory management is not great, mainly because it's a serverless runtime. So it'll just allocate, just keeps allocating from the WASM page, and then when it's done, it's just done. Like it just the runtime will free it, right? Because technically, if we think about it, the Zig WASM code is running on top of the spend runtime. So in that case, then we're going to just free it when we're done. And that's kind of my thought is like, okay, well, if I'll just have like a good enough implementation here, and then if we can do that, then we're great. Or that's the thought at least. So admittedly, this is like I thought about using like an arena allocator here, but then like I said, the more I thought about it, I was like, I don't like when the serverless call is over, it's done. So if I leak memory and the garbage collector cleans it, or basically, if we think about it, Fermyon's written in Rust, so Rust is probably going to clean it up. Let's see. Zig GC. Takes a list of pointers. Why was it I love this. This is pretty bad and mostly just a proof of concept. Same. I mean, it gets the point across, right? Like, I mean, it's a simpler time. All right, so what's the allocator function? Let's see. Call the child allocator. So we allocate with its allocation function, and then we get the pointers. we construct the pointers and return back the memory that gets passed from the child function. And then we just keep track of it. See, so this is a little interesting though, but you're still deferring a deinit call, right? So you still have to say like, hey, garbage collector, when you're done, get rid of it. We get the allocator. Oh, I guess in this case, right? Like when we're thinking about it, a garbage collector, all it's doing is keeping track of the pointers that get allocated, and then it frees them when it's done. So I could see then why this is probably not a great one, because it's not like, it's just like saying when the function's done, just deallocate, where you might have some logic to, have something that does it. But like I guess in Zig's case, like how Zig kind of works, just having it deinit when it's done is probably the way to go. But then at that point, I'm looking at this and I go, well, why would I just not use an arena allocator? If I'm waiting for all of my memory to free at once, why would I not just, allocate an arena and then allocate a bunch of memory, and then when I'm done with all of it, just call free one time? It seems pretty similar to me. Or maybe I'm missing something there, but that sounds very similar. Yeah, okay, cool. So now that works. Cool. So now we're passing the allocator in. And I need to understand why I'm passing a reference to the allocator, I guess, because it's not technically the owner of the allocator. But then I guess what I want is I want the... Why is it even allocating at all? Yeah, this one shouldn't need an allocator. I guess I just put it there. We want the response to have an allocator, right? Because we want to be able to use it for the printing operation. But I thought Oh, yeah. Okay. So here... All right, cool. So we pass the allocator, and there you go. Now we have an allocator. And then I guess here we would just say... See, it's going to complain at me. Actually compiled. Let's go. All right, let's see. Do we write? I guess that's it. I guess that's the only place we do that. And then what we can do is we can say... I did see a pretty cool implementation. I saw a really cool... I need to find it. I saw a really cool router that they basically provide you with every time you pass in an allocator, and then what you do is you use an arena. You initialize an arena allocator every time you call, every time your endpoint gets called. So when you have, let's say, I don't know, something happens and your allocator gets called, so let me rephrase that. You have your server gets a request, and you say, hey, I want to do something with the request. Your response is then an arena allocator under the hood. So when you get a new response, it creates a new arena, and then when you're done, you just free it at the end, and then that way you know, when your function returns, because it's basically like wrapped in a middleware. The middleware just frees the memory when it's done. So it does all of the stuff and then it's done, which I think is pretty cool. I guess we could say like response allocator here, which takes self. I'm thinking, do I really need this? Because I can just access the allocator under the hood. I guess if we don't want to pass the reference. So let's see how this would look. I think I use an allocator here. Yeah. So then const response. Yep. So it returns the response allocator here. And then we pass it down through. Yeah, because if we did this, so let's actually give this a try actually. So if I all right, let's see. I like this because then conceivably you could wrap it in something else. So you could do like a yeah, I think you could do some other kind of allocation there. But hmm. Hmm. All right, I think that works well. Um we probably should pass debug down as well. Okay. So yeah, let's see. Standard dot heap dot wasm allocator. Yep, there we go. Oh, I'm in the wrong folder. I wonder if we could do like some log levels. That might be kind of nice. It could be really nice actually if we set some log levels. I could actually be really into that if we set some, like do some logging. I wonder if we could build like a logging interface. Let's look up. Is there Zig logging? Logs. Excuse me. Spring is in full force, I tell you that much. Okay. So pool size. What's log format? Interesting. I'm intrigued. I usually scoped log with constant log standard. Standard log dot scoped. Is it, wait, does the standard library have logs? Would you look at that? So the only thing that's going to be kind of a problem here is it depends on where it prints out to. Oh, prints to standard error. Standard log dot scoped. Scoped. So let's take a look. Scoped. Debug. Where do I call standard.debug.print? Okay. All right, so I guess in this case then, right, we would do like we. All right, how do we even use this? Let's take a look. Oh, interesting. My project, nice. Standard. Oh, interesting. Okay, so then that would be kind of cool. Because what if we did like a request level scope? Ooh, that would be hard though, because we don't have any context yet on the requests. So each request. Oh, actually, we do. We do. Router. So this would go. Is this route request? No. Rate static routes. Methods, route requests. This is where we'd put it. So all right, get out of here, man. Let's see. There we go. All right, so we would pass it a scope. Then we say this here. And we pass it. Oh, so we have to pass it a logging function. Oh, okay. All right, let's just try to do this on main first, and then we can import it. So if I did standard. So we could say like pub const log options. So what's the standard implementation then? I guess we could look at that dot log. Okay. So right, where's standard options then used here? Just there? Oh, must be named standard options. Okay. That's interesting. So it's like a global. That's interesting. So we'll do .info. Okay, so then I guess my question is, do I have to pass it the log function, or could I just do like log fn equals standard dot log dot default log? Like that. All right, let's give it a shot. and see what happens. So if I do standard.log.info, starting server, I guess this would actually be like technically more accurately received request, but oh, okay. There we go. Cool. That is really cool. Okay, so we set the options here. So I guess my question is, so here's my question. So if it should, but who knows? We'll see. Standard or const log equals standard dot scoped or standard dot log dot scoped request. Interesting. Good to know. Thanks for the link. I appreciate it. The default log level is based on build mode. Interesting. That's cool. I like that a lot, actually. That is very nice. That's very cool. Okay, cool. All right. Yep. Sorry, I missed your little part up here. So I can just get rid of this. Awesome. Cool. So we can do a zig build. We can go to zig out, spin up. Oh, I love that so much. I loved scoped logging, which I know is like kind of a funny thing to say, but like, I don't know. Had to kind of do that by hand for a while and go, because you didn't have a slog yet, so it made it kind of difficult. But this is very nice. I like this. This is the way. Oh, that's the wrong one. Cool. All right, let's see. So we ideally want to pass it into. Oh, I guess what we could do is we could just say like a response.log. Log function could be nice if you need to log to a file. Yeah, I guess that would make sense, right? Because you could write a function that does both. So it'll like call the default log handler and then also print it out to a file. It'd be really cool. And that would be really cool for things too. Like if you wanted to like stream logs to like over a message bus or something, you could just have like your log function passed in that just says, hey, by the way, it's also gonna send this to MQTT or whatever. That'd be really cool. I wish I want MQTT with Zig. I found a static library that could potentially do it, and I want to try it, but I haven't gotten around to it yet. That would be so nice though. What's yeah, that's not even a thing. It returns a type. So how would I? Like, what if I want to embed it? Like, if I wanted to go here, and I go response. Yeah, it shouldn't be. It shouldn't be on the request. We'll put it on the response. So we'll say like like response. Is this even gonna work? I guess not, because it's like, can I just do this? Make it a const inside. Oh, I always forget that I could do that. That's a good point. So we could say like const log equals that, and then I can do like actually, yep, I don't have access to self here, so we'd have to do like self dot. Yeah, but if I want access to it from within a function, right? Yeah, okay. I hear what you're saying. No, no self, just okay, yeah. But so here's my question though. So if I'm like in a function here, right? I'd have to do like HTTP request or not. Nope. It's response dot. Like if I want to access the logger, from outside of the scope, because we remember that the HTTP response is like part of. We're gonna use it as part of the like it. Yeah, does that make sense? Like the HTTP response, we're gonna we use elsewhere. It's we're referencing it in functions. Oh, comp time field, nice. So I do like log comp time. Or do I do it here? Yeah, comp time log. What if I just do like this? Yeah, that's not gonna work. Huh? What does that even mean? Function comp time comps. Oh, so like create a log function. I see. I see what you mean. So we do like yeah, that's not a bad idea. Yeah, any type. Oh, that's what you mean. So that's the type. Because okay. Let's give it a shot. Comp time log fn constu8 any type. So that was let's remove this. Expected a return if I expression. Oh, I need a return type, which is I think void. Maybe it's type. Like it returns the type. Hold on. What if we just say it's a type? Like, can I just do this? So then I could do like self dot log. Okay, and then we could arguably we could say we could just do response dot log dot info. This is a log. There we go. Yeah, if it's crazy that it's just that simple, right? It's just let's just type. I think that's the thing that trips me up the most with Zig sometimes though. There's a lot of times where it's like, okay, what is any type? Or what is type? Like, sometimes it's like it can get a little confusing on like when you need to use those because they don't feel. There's a lot of things in Zig that feel good because they're like really good low level kind of primitives. But then when you kind of reach out to some of the higher level stuff, it's like, All right, what's going on here? Why is this working the way it is? Don't get me wrong, I like it. It can be very fun, but I think it's one of the things that, like, as I've learned the language more, it's the thing that I'm struggling to master is like, when do I use any type? They can't comp time fields are kind of weird. They must be assigned default value and can't change, basically just const declarations in disguise. Yeah, that makes sense. And I guess when we think about it, like in this case, that makes a lot of sense, right? Like for what we're using, completely fine. I never want to change the scope of the log. Well, that's not entirely true. I think that's fine for now. I think we might need to provide some ways to handle that, though. But I think that works well enough for now. I guess you could probably provide like a comp time config item. So like if I go here, right? We could probably do like could I do a comp time field? Like if I did here, if I did a comp time scope name. What is this? At type.enum literal. Like could I do what was that? Like could I do a .enum literal? And then I could do like log equals, or here we would do like so you can't change the default. Right. So like I can't say like self.log equals. So if I go like this won't work then. Let's see. Value stored comp field does not match the comp time value of the field. Yeah, that makes sense. So what if I just say like yeah. That makes sense. I would really like a way to pass it in. You can try to init setting log equals log.scope name. Yeah, I kind of figured. So like if we say this is a const u8, or no, we want the like this, right? So the type of standard enum literal or dot enum literal. Okay. Oh, I wonder if we did this instead. So if we log is a type, and we just say log. We go down here and we say log equals scope name. Wait, hold on. What if we did like that? And we say log type const log like that, right? Dot log type equals log. That's actually really interesting. Yeah, but it requires literally everything now to be a comp time struct. Right. So because of that, now it's like, okay, it was all comp time structs the whole time. Yeah. I'm intrigued, but I don't know if I want to do that right now. But it is good to know that we can we might be able to do something. Yeah, so rather than doing it as a comp time field, we just say it's like a type. But like the type isn't known, right? Yeah, there's no way to change it from default. Yeah, unfortunately. I wish we could change it at compile time though. You know, that would be really nice. Because then I mean it's not like all of those we would just say like have to be constants, right? Like they have to be comp time values. What was that function? This one here. So let's see if they do anything interesting. This seems like a lot. What is L? Inline. Yeah, it seems like way overkill. Yeah. So here's the thing. Like I understand that I can't change the value, but I kind of don't like that. All right, let's see if they use but they don't have any scoping here. Yeah, the ideal thing would be is if we could like somehow scope a request ID. You know, like we would. I mean, but it's serverless, so there's not even really going to be a request ID unless it's passed down from Fermyon. Yeah, I'm happy with this for right now. So then can I hold on? Can I even further scope it? So can I go like response.log, hold on, const test logger equals like response.log.scoped. Like, can I do this? Oh, sad. I guess if I wanted to, though, I could just say, like, I could just, like, provide a new scope. I guess that's how you would do it. Like, I don't know why I would want a response level scope. I guess if I wanted, like, a global scope. I could say, I could do this, though. Yeah. So we'll say that, and then we can do here. Then what we could do is response. So we could do that, and we could go like here, and then we can go down here, and we can say if so that's not gonna work, is it? But it's not. But we'll see. Can I do like pub var? Oh no. Okay. That's cool. You know what else we could probably do? Um, this one might be a little weird, but like, I wonder if we could use like using namespace. Like, like, could I do like using namespace? Uh, yeah, but that's not really like what I'm going for, because that really what that does is that means that I could do this up here, which basically says I could do like HTTP response dot log dot scoped. Yeah, no, that doesn't even work. Oh, I guess it'd be like this, just this. It'd be like dot scoped. Yeah, no. Yeah, I don't want to do that. I don't want to mess with that. I like what I had. Oh, there we go. It would be cool if they had like a scoped interface, kind of like the allocator interface, where you had like child scopes. That would be really nice, rather than having to declare a scope every time. Yeah, that's really nice. I like that a lot. It would be really cool though if I could just hmm. It would be really cool though if I could have it route like if this part here could be what this is, like this part. That would be really nice. That'd be super nice actually. All right, I think that that puts us in a good spot. I think for right now. We'll clean it up a little bit more throughout the week. I'll be doing a couple streams throughout the week just to kind of clean this up a little bit. Um, like I said, we're gonna be over on Fermyon's YouTube channel talking on Tuesday of next week. I can actually get the details about that for those of you who are interested. I'm also going to be streaming it live on Twitch. So if you are interested, let me know. And I would love to have you guys come stop by, support, say hello. That would be really cool. So let me grab that link for you. I have it right here. Let me just make sure that it's a good link. Cool. All right, awesome. All right. So here's that link for everyone. Let's see. So yeah, we're gonna be streaming on Tuesday. So feel free to, you guys are on YouTube. Feel free to, notify yourself. And like I said, I'll be going live that Tuesday as well. To kind of on this channel as well. So if you want to watch it on Twitch, I would appreciate it. But if you don't and you want to watch it on YouTube, feel free to go over to the Fermyon stream, and they'd love to have you. Yeah. So thanks to everyone for stopping by. I appreciate it. Yeah, feel free to reach out. I will also be on the Discord, so feel free to stop by, say hello over at the caravan. But all right, everyone, let's find someone to raid. Let's see, who should we raid today? Bad Cop is streaming. Let's see, browse, software and game dev. Bad Cop. Let's see, anyone else? Is there anyone on the Zig Discord? Let's see. Let's take a look. Doesn't look like it. All right, cool. All right, well, if that's the case, then I think we'll just raid Bad Cop. Make sure to say hello. Be nice. And yeah, thanks for everyone for stopping by. I appreciate it. And yeah, let's do a little raid. All right, I'll see you guys all over there. Thanks for stopping by. Take it easy. Bye.